discussing about material balance. And material balance is the fundamental tools of chemical engineering. It is the basic for the analysis and design of chemical process. In chemical processing, we deals with transformation of raw materials of long value into process of high value, and in many cases unwanted byproducts that must be disposed of. In addition, many of these chemical compounds may be hazardous. The material balance is the chemical engineering tools for the keeping track with engineering and living the process as well as what goes on internally. Without account material balance, it is impossible to design or operate chemical plants safely and economically. We have four type of material balances. The first is flow sheet material balance model for continuous process operation in the steady state. The second is mixing and blending material balance. And the third is flow sheet material balance for non-steady state process, either continuous or batch. And the fourth is process data analysis and reconciliation. A flow sheet of a schematic diagram of process which should be various level of data like equipment involves and how is interconnect by process piping. A flow sheet material balance show the flow rate and composition of all streams entering and leaving each items of equipment. Most of the emphasis on the material balance problem has been on continuous process operation in steady state. And one might ask why. The reason is simple. Of the total tonnages of chemical products produced, the vast majority of produced using continuous state process. This includes oil refineries as well as chemical plants producing large tonnage products such as sulfuric acid, ethylene, and most of the other commodity chemicals, petrochemicals, and rate and products quality and calculated backwards through the process. Intermediate specific cations would be used as a additional starting points for calculation, as will be seen later in the note. Such an approach goes against the output from input structure of the process and can leads to several numerical instabilities. The growing abilities of digital computer in the last 1950s leads to the development of the first material balance programs such as IBM, GIFS, and other. Almost every major oil and chemical company soon develop in-house programs, of which Moonstone's Flowton is the best known example. By the 1970s, several companies specializing in flow sheet programs had come into the existence. Today's companies such as Simulation Science, Spins provide third generation version of steady state flow sheet simulation program to provide a wide range of capabilities and are relatively easy to use compared to early version. Dynamic simulation is less advanced than the steady state simulation. This is due in a part to the lack of emphasis until recently on the dynamic aspects of chemical engineering operations. The situation is changing rapidly due to demands of improving process control and for simulation for training operation personnel. The companies mentioned in the previous paragraph have already added dynamic simulation to their products lines. In addition, several companies such as ASABB Simcon offer training simulation for the process industries. The material balances methodologies, there are two types of steps involved in applying the principle of conservation of mass to chemical processing problems. The first is on the formulation of problem and the second is solution. By formulation of the problem is meant determining the appropriate mathematical description of the system based on the applicable principles of chemistry and physics. In the case of material balance, the appropriate physical law is conservation of mass. The resulting set of equation is sometimes referred as a mathematical model of the system. What is a mathematical model means will be made clear by the example contained in these notes. However, some general comments are in order. First, there may be a number of mathematical models for varying the level of details that can apply to the same system, which we used upon what aspects of the process we will wish to study. Now, a topic of conservation of mass. The principle of conservation of mass is fundamental to all chemical energy engineering analysis. The basic idea is relevant, easy to understand, since it is a fact of ours. Suppose we are required to prepare 1 kilogram of a solution of ethanol in water such that the solution will contain 40% of ethanol by mass. So we weigh out 400 gram of ethanol and 600 gram of water and mix that together in larger beaker. If we weight the resulting mixture, making appropriate allowance for the weight of the beaker, experience say it will weight 1000 gram of 1 kilogram and it so these are all about material balances.